All right, I just kick off the recording. So, welcome everyone. Welcome to into another session and blockchain new and truth scam. I think this is like our 14th contact, so we considerable progress, and I admire tenacity. It's been a lot actually. So as some of us have been combining it with cool activities. But we kept pushing, and I think that's amazing and applaudable. So today's class we're going to be having Idogwu Chinonso take us on Chainlink Oracles. I don't know, Idogwu Chinonso, can you hear me?
Yeah, I'm here. Good evening.
Yeah, good evening, Chinonso. All right, so I think we
Hardly
could
hear.
just get started.
Okay. Good evening,
Sorry.
everyone.
Yeah, good evening.
How's it's my volume enough? Okay, I think I heard someone complaining about not hearing me.
Yeah, I think that
Am I
was
audible
that's
enough?
what I was
Okay.
about.
Okay.
Yeah, you're audible enough. I don't know. It might be
Okay.
from Samuel said. Samuel, can you hear us clearly? Hello, Ezekiel, Samuel, are you there?
It's
Um,
probably is having network issues.
I think we could just yeah.
Yeah. Good evening, everyone. My name is Idogwu Chinonso, just like the listeners mentioned. And today I'll be taking us on blockchain oracles. Then we'll be diving deep and specializing on Chainlink Oracles. So today's class is going to be mainly just theoretical. We are not doing any coding session today. Coding session will be happening on Tuesday, where we'll be working through a contract utilizing a Chainlink Oracle. Without further ado, I think I would like to share my screen and just kickstart the class. 1 minute. So sorry, can you guys see my screen? Can you guys see my screen?
Yeah,
Okay,
we
Yeah,
can.
I can see it from my
okay. Just like I said, today we'll be touching on blockchain oracles, majorly a theoretical class. And in today's class, we'll be touching on what oracles are, we'll be touching on importance of oracles in blockchain application, overview of different types of oracles. We'll get to understand randomness in blockchain, how the challenges we face while generating start by just getting a baseline of our understanding or what comes to our mind when we hear the word Chainlink Oracles. Bentek, Abiu, your hand is up, was it?
Yeah, your voice is not audible. I can't hear anything.
Wow, okay. So how is it now? Is my
I
voice
can see
better now?
some. Okay,
Yeah,
okay,
since
yeah, 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 yeah.
okay. So I'll just basically listing out what we'll be covering in today's class. So I mentioned I'll be covering what oracles are, covering on importance of oracles in blockchain application. We'll also be touching overviews of different types of oracles. We'll touch randomness in blockchain and challenges we face generating random numbers on the blockchain. Then we'll be diving deep into Chainlink. We'll finally touch on the how Chainlink provide reliable and secure data to our smart contracts, and that's what we're ending our class for today. So I would like to start first of all by asking. I would like this class to be interactive. So I would like to pick someone, ask the person what comes to mind when you hear of the word oracles and blockchain. So Nemeka, are you on the call?
Yeah, yeah, I'm on the call.
Okay, so I'd like to ask you a question. When you hear the word blockchain oracles,
Oracles. Um, Oracle. I think is like kind of. I think Oracle, without blockchain. So I don't really know what it means, but what comes to mind is something that knows a lot. So I'd say kind of database or something that you can go to get information about almost anything.
okay, okay, that's nice. That's nice. Then Harrison, you have your hand up, so you can speak.
Okay. I know about Oracle a little bit. Just let me say, like in a platform now that wants to relate with an external currency, like let's say USDT now. So let's say that platform have their own token. So I think Oracle is just a means of connecting it so that you can convert kind of like their own token to that external USDT or something like that.
Okay, okay, you have a point. You are close, but you still need to retouch that. So I'll be clarifying on that during class today. But yeah, you have a very good point there. So thank you both very much for your explanation or your understanding of Oracle so far. And as Nigerians, we know that okay, once we hear the word Oracle, one of the major things that comes to our mind is probably the deities we have in our villages and stuff like that. But if you take it to an extent, we could apply that knowledge we have, or that understanding we have about oracles into the system we have today, and it's still going to make perfect sense. So, for example, we could say, okay, traditional oracles are channels or mediums that can connect our real world to the ancestral realm or to the realm of our forefathers, like the way they depict it in Nigerian movies. So that is a good definition of oracles in the traditional sense. So we could also use that same definition or bring in that same definition into what we know today and in the blockchain space. So basically, blockchain oracles are trusted data source. They are more of like bridges that connect the real world to the on-chain world. The on-chain world is like where our smart contracts live in. It's more of like the blockchain itself. Because basically, I know so far so good. We've written a couple of smart contracts. We understand what smart contracts are. We understand the architecture of the blockchain system. But one thing I don't know if you guys know is that the EVM on the blockchain is actually sandboxed. What I mean by sandbox is that the EVM is actually isolated from the real world. There is no way for the EVM to actually communicate or get data from the real world. And it's actually difficult for the real world to in the same way, communicate with the EVM. It was designed this way in order to create a more of like a secure platform or a secure arena where the blockchain or where the EVM can operate. So since we know that the EVM or the blockchain, its sandbox is cut aside or is separated from the real world, how then do we get data from the real world into the blockchain? For example, you're building a smart contract, you're building a swap, you want users to bring in USDT and get ETH. And it's possible to write your smart contract in Solidity and get it running. But one of the hindrance, one of the issues you are going to be facing is how do we actually get the price of ETH at that moment? How do we know how many ETH are going to be given out to users if they bring in the USDT? And the price of ETH is actually being determined by events in the real world. It's being determined by the price of demand and supply in the real world. So an EVM or a smart contract at this point has no knowledge or has no understanding, knows nothing about the price of ETH at this moment. So with this problem now, there's now a strong need or there's now like a strong drive for we to actually have platform or have a system that can connect the on-chain world of our smart contract to the real world which we have today. And that is what oracles are. So oracles are basically a bridge between our smart contracts and the real world. They help to transfer data to and from these both parties. So that is actually a very good or like a simplified overview of what blockchains or what blockchain oracles are. So ideally, basically, oracles are meant to be trustless, meaning that okay, we do not need to actually trust them before we can operate them. That's because we trust and we know that they are basically supposed to be operating on a decentralized manner. I use the word supposed to because as of today, we have centralized and decentralized oracles. In as much as the main or actual mindset which people had when they were creating oracles is we need something that is also decentralized that can bring in a unified data source to the blockchain system. But today we have centralized and decentralized oracles, and it's actually a very good thing. So, but we still use or when we use oracles, we basically trust the implementation, we trust the logic, we trust the medium in which these oracles are bringing in information from the real world into our smart contract. So basically, oracles work in three set of functionalities or in three mediums. So oracle basically get data from the off-chain source, that is, they get data from the real world. They bring this data into the blockchain ecosystem. Then they perform some kind of consensus mechanism. They kind of like carry out consensus in order to determine the real information or the legitimate information to pass out to our smart contract. Then the third step, what they do is they make this data available to our smart contract. So that's basically the three step or the three functions which blockchain oracles perform. They collect data from the off-chain source, the real world. They transfer this data on-chain. Then they make this data available to our smart contract or smart contracts that need this data. So here comes the big question, which is why do we need blockchain oracles? So if you've been paying attention so far, I'm sure I've mentioned multiple times why we need blockchain oracles and the need for secured information or data on chain. So basically, blockchain oracles are needed in order to bring in data, bring in real world data into the smart contract, into the blockchain ecosystem. While writing smart contract or while building that, we'll be needing real life information such as the price of goods and services, the price of stock and commodities. We need weather conditions, we need sports scores, we need events from elections and stuff like that. Imagine if you are building a blockchain betting platform where users can come, just like we have Bet Ninja, Sporty Sorry guys, I got kicked out due to network. Where did I stop? Sorry. Jeremiah. Guys, are you guys still on the call?
On the call.
Yes, I can hear you.
Yes, we can hear you.
Yes, you can
Yeah,
hear you, sir.
that network issue.
We are talking about the three functionalities of oracles before you
Oh.
got kicked out.
So basically, if I got you correctly, I stopped at
So you stopped at why we need oracles. You said that it to bring in data, something about betting, something, event from election, etc.
okay. Can you see this slide? Guys, can you see this slide? Hello, guys, are you guys see there?
We can see.
Yeah, I can see it.
Okay. So so far so good. I think I've covered what blockchain oracles are and why we need blockchain oracles. Is there any confusion so far, or are there any questions so far? Okay, I can take that as a no. So let's continue. So basically, how blockchain oracles work. Just like I've mentioned previously or multiple times, blockchain oracles actually collects data or retrieve data from external sources, from like the outside world. Then they validate this data they collect. Initially, I mentioned that oracles were actually designed to be decentralized. So the main art goal or the initial art goal or thought process we had towards designing oracles was okay, we needed secure and decentralized means of getting information from the outside world to the blockchain system. So one of the main issues now is that if you have a decentralized medium or decentralized avenue of getting information, for example, if each and every one of you in this call now, if I'm to ask, okay, what since most of us here are students of UNN, if I'm to ask, what is the current school fees or what is the current school fees in your individual department? We know that okay, some of us now might have different prices, which we might have told our parents, our uncles, and stuff like that. So if each and every one on this call now is presenting a different price or a different fee, how do we come into conclusion on the actual or the correct price of school fees or the correct amount that is the school fees for this session? So if you apply that now into the example I have, okay, I want to create an exchange that allows users to swap USDT to ETH. And 50 people are telling me the price of ETH at that moment. There's every possibility that out of those 50 people, 20 might be giving me the wrong price. Not necessarily because they want to give me the wrong price, but because based on internet connection or stuff like that, the price they have at the moment is outdated. Some are giving me the correct price. Some intentionally want to be dubious and are giving me a very wrong price. So at this point in time, since it's decentralized, we have it's open that 50 people can actually run and come into consensus on the price of ETH at that moment. So how do a blockchain oracle now decide the actual amount or the final price of ETH at that very moment?
Sorry, sir. Please come again.
From these different nodes. They can also choose to choose a specified price range based on the highest amount of attestations to that particular price range. So there are different logic which these oracles can actually implement in order to get the final price of or the final data they want to bring on chain. But one thing remains the fact that Once blockchain oracles retrieve data from the external source, they really need to validate this data. They need to carry out external or extra computation in order to process this data and make sure that they're actually getting the legit or the authentic price or the authentic information that's needed on chain. So they have to actually validate this data before sending it to our smart contract. Just like I said, it is basically to ensure integrity and also prevent malicious activities from some users or different node operators. So there are different ways by which these oracles actually carry out this validation. They can carry out a whole lot of like different cryptographic techniques. They can also use consensus mechanism, just like I've mentioned, to come into finality on the actual price or the actual data that is being brought on chain. For example, I've given you an example already that if I'm building a smart contract and exchange, for example, Binance, and I want users to just swap between ETH and USDT, I have my front end, I have my smart contract. User comes to our platform, click transfer USDT to our contract and is expecting to get ETH back. After the user must have interacted with our contract is supposed to make a call to an oracle. This oracle will give you the price of ETH at that moment. If that price of ETH is being returned back to our contract, then our contract can perform the logic and calculations on how many ETH is going to actually transfer to that particular user that wants to use our platform to carry out that swap. So for the past few minutes, I've been basically defining Oracle and talking about Oracle as a centralized entity. So I would like to actually break this down more. Just like I mentioned, Oracle is actually designed to be decentralized. An Oracle network is actually supposed to be more of like a decentralized network of different nodes or different sources of data coming together in order to come into consensus and transfer the data or the legitimate data on chain to our smart contract. So just like this slide depicts, we have our world data source. It could be data from IoTs, it could be data from banks, it could be data from weather, elections, football scores, and stuff like that. So basically, these data are sent or are collected, consumed by a decentralized Oracle network. Each box here in this network is an individual node running as an Oracle node or a node for that Oracle. So each of these nodes here receive data from the external world. They come into consensus. They get the final price of goods or the final information that has been authenticated. Then they transfer this data to our smart contract. A whole lot of smart contracts, Uniswap, and a whole lot of other swap or contracts on the blockchain now are being powered by blockchain oracles. So, do you guys have any question? I think I mentioned about node just now, and I don't really know if you guys know what a node is in the blockchain system. You've been writing smart contracts, I feel you guys should know what a node is. Um, Chidubem, are you on the call? Chidubem,
Yes, I'm here.
okay. Do you know what a node is?
Yes.
Okay. What is a node? Sorry.
I know it's just um, some group of networks that are connected to each other that perform some particular function.
Okay. That is actually close to the answer. It's obvious you have a good idea of what a node is. But basically, a node is an individual entity in a network. So multiple nodes come together in order to form a network. So in the sense of a decentralized Oracle system, you have multiple parties coming together as node operators. So So each entity now in a network is a node. For example, everybody now on this call can choose to be a node for Chainlink Oracle. So what you basically do is, okay, you run a software on your system, and the software in your system is going to be transferring data or information that is being requested by smart contracts on chain. So if you are running that software, I'm running that software, Henry is running that software, every other person on this call is running that software. That means each and every one of us now is a node. And just like I've been trying to mention before, if each and every one of us here is bringing data on chain, there needs to be a way to actually come into conclusion or come into finality on the final detail or the final data that each of us has contributed or each of us has come together to deliver. So that's basically what blockchain oracles do when they talk about consensus on blockchain oracles. So blockchain oracles get data from off-chain source. Each and every node gets this data. They come into consensus, they come into conclusion, they come into finality on the final state or the final status of that information. Then they pass that information or they transfer that information on chain to our smart contract. So next we'll be touching on is types of blockchain oracles. So there are basically two types of blockchain oracles. But these two types of blockchain oracles are spread across two different classes. So we have two types of blockchain oracles. We have decentralized and the decentralized oracles. But each of these types of oracle is being spread across two major groups: the software oracles and the hardware oracles. So first of all, let's touch briefly on software and hardware oracle. Just give it a brief touch. Then we'll go into majorly decentralized and decentralized oracles. So a software oracle is basically an oracle implementation or a type of oracle that fetch data from online source. It basically gets data from online informations. It doesn't need a physical entity or physical device and that to get this data. So it gets data from online source such as um, the price of goods and services. It gets information such as basically information that you can get online. The result of a football match, the scores of football match, basketball match, and stuff like that. So that is a software oracle. While a hardware oracle is actually a physical implementation of an oracle. For example, a hardware oracle can be used to transfer data from IoT devices, just like temperature meter, weather recorders, thermometers, and other informations. For example, a hardware oracle can also be a barcode scanner. If, for example, you are building a smart contract, and that smart contract now is supposed to get data or track the delivery of goods from one location to another location. We know that, you're supposed to transfer a good or like a particular package from Enugu to Abuja. So we want to create a kind of like on-chain smart contract that's able to track the location of that good at every period of time. So you can have a barcode scanner and there will be a barcode on that good. That at Enugu, we use our barcode scanner to scan the good. So what the barcode scanner basically do is scans that good, verify that this is an authentic good. Then it sends the information to our smart contract that this goods has been scanned at this very position. So this goods is authentic and it's verified that this goods at the moment is at Enugu. So our barcode scanner at that moment is more of like an IoT device. So we can look at that barcode scanner at that moment as a hardware oracle because it's basically transferring data from the reward source, from the reward into our smart contracts for us to be able to track the location and the authenticity of this good at that very moment. So that's basically a hardware oracle. So I know this might be like a simplified and an overhead view of hardware and software oracles, but I intentionally just want to touch briefly on that because I want us to talk more or specialize more on decentralized and also the decentralized oracles. So share as blockchain developers, you guys are already blockchain developers because you've written a couple of smart contracts. So I'm sure you guys understand what centralization and what decentralization mean. So Favor, are you on the call? Favor Lawrence, are you on the call? Okay, can you your background is kind of noisy, but can you tell us or differentiate between centralized and decentralized oracles? Or sorry, decentralized and decentralized in the blockchain system in general, not necessarily oracles.
Hello, can you hear me?
Yeah, I can hear you.
Decentralized is more like a distributed form of network. Why centralized? Centralized is there's a middle
Sorry,
person. Can you hear me?
the noise from your background is too much. Could you at least shift a little?
You can't see my body. Is it better now?
Yeah, it's better now. It's better now.
So I was saying like decentralized is like a distributed form of network. Then centralized network is more like there's a middle person or there's someone controlling the network as a whole.
I think your environment is noisy.
It's better now. It's better now. Okay. So basically, I think Favor she got the answer correct. A good one. So when it comes to oracles, centralization and decentralization basically mean the same thing as in our normal blockchain ecosystem. When we talk about centralized oracles, we are talking about oracles that are being controlled by a single organization, oracles that are being controlled by a single entity. So most of the decision or most of the information is being channeled through a centralized and an individual authority. A good example of a centralized oracle is okay. Imagine if UNN, for example, decides to create a smart contract where users can um, basically, yes, yeah, a centralized oracle or not necessarily. Imagine if UNN create a smart contract or a tab where users can go and interact with more of like an online platform for users to actually go and get details of their results, get details of your exam score, your test scores and stuff like that. Okay, because let's say okay, UNM feels that the information on the blockchain is more secure and more temper proof, meaning that okay, they can.
I can't hear you.
Can't hear you, sir.
Network.
Actually transfer. Can you hear me? I think someone was complaining about network just now.
Yeah, we can hear you now.
Yeah, we can hear you now, sir.
Okay. Sorry about that. I think network is bad on my end. So I was just saying, okay, if UNN, for example, decides to implement a student platform, or more of like an e-learning platform on the blockchain, for students to be able to go visit these sites and get the data of their exam score and get okay. Am I still breaking, guys? Okay, okay.
No, no.
It's clear now.
Okay, okay. Thank you very much. So, just like I was saying, if UNN decides to create a DApp or an e-learning platform, where users can or students can basically visit in order to get their test scores, or in order for users to actually even place bets. Imagine if there's a platform in UNN that you can stake. I can come and say, okay, I want to write physics or maths 121, and I want to stake that, okay, I'll get an A in maths 121. So I'm betting 100 USDT that if I get an A in maths 121, UNN will give me double the amount. But if I fail maths 121, if I don't get an A in maths 121, UNN will actually take back like my 100 USDT. I basically lost that 100 USDT. So if UNN was to create a platform like that in order to incentivize students to actually read, prepare, stake, if you know you can do it, then stake your amount, write your exam, you get your score, you get your money. So if UNN were to design a platform like that, there's actually going to be a need for a trustless source of transferring information or results to the blockchain. Students now have to have like a medium for that they trust, because I can basically say, okay, I wrote this exam and actually got A, but CNN revoked or reduced my result in order for them to take my 100 USDT. So UNN is actually going to need a decentralized source, or is going to need more of like a source of transferring this data from the real world into the blockchain that the users or the students can trust. But if UNN chooses to, okay, to operate more of like a platform or an oracle that they control themselves, that only UNN has access to, that UNN basically controls, it sends the data or your result, your exam scores and everything to the smart contract automatically. And there's only one implementation of that oracle, or necessarily, let's say, even if there are multiple implementations of that oracle, but they are all under the control of UNN. It means that oracle is a centralized oracle, because at this point in time, all control over that oracle, or all control over the implementations of that oracle are being centralized on UNN at the moment. So that is a simplified explanation or a simplified definition of what a centralized oracle is. So we'll be going further into talking about centralized oracle by breaking it down into five different categories or five different points. So just like I mentioned, centralized oracle have a centralized control. They are basically being controlled by a single entity or a single company. Using the example of UNN in the illustration I just made, UNN having an oracle that sends information or results of students to the smart contract they designed is more of a centralized control. So basically, that oracle is a centralized oracle. So another thing or another key aspect of centralized oracle is that users have to basically trust in a single source. So we as students, for example, need to trust that the information that UNS Oracle is going to be sending to the smart contract is authentic. We have to trust that, okay, if I'm going to use that platform, it means I trust that, yes, UNN is going to be sending my correct score or my correct results to that smart contract and not alter it because they want to take my money or stuff like that. So when it comes to centralized oracles, users have to trust in a single system, in a single implementation, in a single source of data, which is the data or the oracle that is being controlled by this company or by these institutions. Then another thing, another key aspect of centralized oracle is the speed and efficiency. Centralized oracle are mostly faster than decentralized oracle. And if you try to look at it from a logical aspect, you know that, okay, when it comes to decentralized oracles, there's a need for consensus. So basically, the centralized oracle or decentralized oracle have to get information from external source. We have multiple nodes running that particular oracle. So each of these nodes have to get this information from external source, then come into consensus on the actual state of that particular data. So coming to consensus now might take time. Imagine if you have 50 people sending information to the oracle in order for the oracle to come into consensus. Just like I'm having bad network today, some of the nodes now might also be having bad network, and the data they are sending in for consensus might not come in time. There might be a lag period. And this oracle now might have to wait in order to get the data from this external node in order for it to come into consensus. So when it comes to speed and efficiency, centralized Oracle might actually be faster because a centralized Oracle now doesn't need to wait for consensus, doesn't need to wait in order to come into conclusion of the current state of the blockchain. It basically just uses one source, get the information, send it on chain, and that's it. But a decentralized Oracle might need to come into consensus, might need to check or validate this data that are coming from different sources to cause, and the other is going to cause a delay in time. So that's it for the three basic things. That is centralized control, trustness, then speed and efficiency. Then another issue of centralized oracles is vulnerability. Because basically, if UNN is to implement, using that example we are already on, if UNN is to implement a platform, just like we mentioned, that is able to allow users to place bets or to stake an amount that is going to be double or triple depending on their results in a particular exam. Then imagine if there is a hacker as a student or that is able to actually hack that oracle since it's just one oracle. Imagine if a student now can actually hack that oracle and send in a wrong score, even if that student fails because the students can actually hack the oracle, then trick the oracle into sending a wrong score, like an A, to the smart contract, and that student is actually going to get double the actual amount he stakes, while he's not supposed to actually get anything at all. So, in terms of vulnerability, centralized oracle are more prone to attacks because you just have a single source that hackers can actually just attack. Once you attack that single source, you hack that single source, you are good to go, and that is it. There's just one implementation of the oracle. There's just one single point of attack that you need to focus on. Even if you are not able to hack it and get your data into the oracle, imagine if you can create more of like a DDoS attack, just destabilize the oracle at that very moment that the oracle is not able to send in information from the outside world to the smart contract. And that might cause more of like a delay and that might cause like a disruption in the normal flow of the oracle or the DApp as intended. So in as much as centralized oracles are vulnerable to attack, centralized oracle are also less susceptible to Sibyl attacks. So Sibyl attack is a form of attack on that is very popular on the blockchain. Is more popular around decentralized over or take over like or take gets highest power in a decentralized network.
Sir, we can't hear you.
Wow. Okay. Sorry about that. Sorry about that. Can you hear me now?
Yes, we can hear you now. You stopped at centralized oracle less susceptible to civil attack.
Okay. 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 Thank you very much. So, Sibyl attack is a form of attack on the blockchain. It's more popular among decentralized systems. So, let me give you a real. It's easier to explain it with an example. So, imagine if each of us on this call, we are about 14 people on this call. Imagine if the 14 of us now are to act as nodes for a blockchain. Each of us now is a node in Ethereum network, for example. And each of us is supposed to send in data on the current states of the Ethereum system. We're supposed to send in data on transactions and stuff like that. So normally, the way consensus works is that each of us, the 14 of us, send in our data. Then out of the 14 of us, the score or the data that has the highest attestation. For example, if out of the 14 of us, 9 people are sending in the same information and the remaining 5 are sending in a different information. It means that those 9 people that are sending in a particular information that is the same are probably the right people, are probably the people sending in the correct information. So in decentralized system, information or consensus tend to favor a set of people that have the longest attestation or a group of people that have the longest engagement or the longest votes. So civil attack comes when a miner or a hacker try to create multiple nodes that is under one control. We have 14 people on this call. Imagine if seven of us now are actually listening or under the control of one individual. There's one individual that is directing seven out of like the 14 people on this call. To know that if that centralized individual wants to actually defraud that system, he just needs to, okay, tell the seven of us now, passing this wrong information. And since you know that, okay, the group with the highest long or the highest attestation actually wins in a consensus system, it means that hacker now is able to actually hack that decentralized network by asking the seven of us, which is more than the other numbers, to actually send in a wrong information. So the blockchain basically, or decentralized system, will basically pick that group of people, the seven people that have the same information as the correct information. Can you guys hear me? I think I lost my information, my network for a brief period of time.
Okay, Nambo, we lost you for a moment.
Oh, wow. So, but were you guys able to get explanation of what a civil attack is?
Yes, sir. You said that in civil attack that the hacker creates more node that sends you the same information. That was the network now stabilized.
Okay, okay. So basically, in a civil attack, a hacker tends or try to create more nodes or more representation of a node in a network in order to gain control of that network. Because in decentralized system, when it comes to consensus, consensus figures the longest chain or the chain or the data with the highest number of attestation. So if a hacker is able to overpower the network by creating more than half of the nodes in that network and sending in wrong information, the blockchain or the decentralized network is going to actually favor the hacker that is sending in wrong information simply because there are a higher number of people voting or attesting to that particular information. So since you have a centralized oracle, that oracle is going to be less prone to civil attack because okay, UNN now is basically the only one transferring information to the smart contract. So they are not concerned about okay, an individual or students coming together now to overpower the network by students coming together to vote for a wrong information because they want to favor a fellow student. So UNN now has prevented an issue like that coming up because you know that okay, since we are all students, there's a kind of solidarity between we students and the students are normally going to vote for themselves or favor themselves over the institution itself. So UNN might want to actually operate a centralized oracle because they want to prevent a civil attack. Though, in as much as they are preventing a civil attack, they are now bringing in more issue or more problem or vulnerability because their singularized or their centralized oracle now can easily be hacked or can easily be attacked, or they can be more of like something like a DDoS attack on the centralized oracle, preventing it from functioning properly. So that is one of the issues or one of the top topics related to centralized oracles. Then the final thing I'd like to touch on centralized oracle are their use cases. So basically, when we are using or when institutions tend to go for centralized oracles, they tend to go for centralized oracles when they know okay these informations that are being sent or they are being transferred by these centralized oracles are single source informations or information that can be accepted even if they are coming from a single source. For example, such as imagine if Oraimo, for example, were to create a smart contract for users to be able to buy Oraimo product via the blockchain using any of the cryptocurrencies they support. So we won't necessarily be angry or won't necessarily be worried that Oraimo is operating a centralized oracle because Oraimo are basically the one specifying the price of their goods. So they can choose to just have a centralized oracle that will just be telling us, okay, this is the price of this good at this moment. This is the price of this airport, this price of this power bank at this very moment. and their smart contracts can consume that data in order to allow users to make this purchase. So this use case now is a use case that we can say, okay, it's understandable. Yes, you can just find operate a centralized oracle, and we'll be okay with that. Another example is, for example, if Premier League, for example, we had to create an oracle that will give out the prize or that will return the result of football matches. So we know that okay, Premier League basically are the one organizing these leagues, they are the one organizing these football matches. And if they decide that okay, if they say okay, the score line of this match is this to this, we are okay with that. We basically believe that because if they can alter the price in the oracle, they can also alter it in real life, and that is it. So that might be one of the use cases that we can say, okay, yes, it's understandable for these companies to run a centralized oracle. So different use case might actually determine the type of oracle an institution or an organization or individual you want to go for when making a choice of the type of oracle to use. So with that, I think I've covered a lot concerning centralized oracle. I've been able to touch the use case of centralized oracle, the vulnerabilities, disadvantages, and also the advantages of centralized oracles. So I think we'll be moving straight up now to decentralized oracles. So decentralized oracles, just like we've been explaining, operate on a network of independent nodes, more of like the way we have decentralized blockchain. We have node operators running independently. So that is how decentralized oracles operate. For example, Chainlink. Chainlink is a decentralized oracle. When it comes to Chainlink, we have multiple node operators. We have multiple individuals that register to be node operators for Chainlink. So each of these individuals that register and accepted by Chainlink are able to send data or able to send information that are requested by smart contracts to the Chainlink model frame or to Chainlink motherboard. So if each of these individuals that register on that Chainlink and are accepted are able to send data to Chainlink Oracle in order to come into consensus, that is actually a decentralized network. Because this network now is not secluded to a singular institution or a singular entity. It's more of like a network of nodes that are sending data from the real world to the blockchain from multiple sources. Chainlink, for example, provides price feed for Ethereum and other stable coins and also volatile coins. And most exchanges like Uniswap, PancakeSwap, and the rest make use of Chainlink. So there's this kind of demand or there's this need for the data that they are getting from Chainlink to not be coming from a centralized source. Because if it's coming from a centralized source, then it's easy for decentralized source to be hacked. And Uniswap, as you know, or PancakeSwap, as you know, is controlling a very, very large amount of money, large amount of tokens. And there's need for informations that these exchanges or that these institutions are consuming to really, really be authentic information. Because any mistake, any misinformation can actually lead to a whole lot of issues. We have people taking loans from Uniswap. We have people taking loans from Aave. And some of these loans now are actually dependent on price of goods at the moment. So any misinformation can lead to liquidation of these loans. So that's why certain institutions or certain organizations insist on having a decentralized oracle, insist on having a network or an oracle whereby the informations that are coming in from that oracle are not just coming from a centralized entity. These information are coming from different organizations, different people from different areas of the world, such that even if there's a downtime, even if one of them is hacked, or even if there's a DDoS attack on one of these nodes, the others can actually come into consensus and give the correct price or a trustworthy price of the goods or commodities that is being requested at that very moment. Then when it comes to decentralized oracle, there's limited need for trust. So decentralized oracles actually aim to minimize the need for trust on a singular entity. So data are coming in from a decentralized oracle are actually coming in from multiple institutions, multiple organizations, multiple parties running their nodes from different areas. So there's less need for we as individuals or we as programmers. So I'm sure these two can actually give me a verified source of information. So that is one of the main characteristics of decentralized oracles in the sense that we do not need to trust a singular entity. We now, okay, our trust now is distributed over the entire network. We just need to trust the network itself and not just a singular entity in the network. So when it comes to decentralized oracle, there's also an issue of security and reliability. Those decentralized oracles are less susceptible to manipulation or censorship. Censorship in the sense that oracle, like it's a centralized oracle now might choose to not send in data feed for a particular user. For example, UNN now might notice that okay, there's one BGS or there's one very intelligent student that's always doing well in his exams, and they're already tired of allowing that student to win. They might just choose okay, we won't be sending the result of this student to our DApp or to our platform that these students can use to stake or bet. And that is censorship because at this moment, UNN have censored out that particular user. But when it comes to decentralized network, it's not actually possible because even if one particular node operator choose to censor out that particular individual, other node operators will still send in data regarding that individual's test score, that individual. So, okay. Then decentralized oracles also offer more security and reliability, just based upon the fact that okay, this is a decentralized network. We have multiple parties coming together to send in information, to bring in this information. So we can trust that okay, this network is actually more secure. Because me as a user, for example, if I know okay, I make use of a particular oracle more often, a particular data from an oracle more often, I can also choose to run a node for that oracle. For example, Uniswap now might be making use of Chainlink Oracle that often. And Uniswap might choose to, okay, why not let's buy a system, keep it to one side, and register that system to be one of the node providers in Chainlink. So we'll be getting our price feed from this external source from, for example, for CoinGecko. We get our price from CoinGecko, send it also to this network. That way now we have our oracle that even if other people are sending in the wrong information, we know that okay, our oracle will always send in the right information because we know okay, we want to actually make use of this price feed. So decentralized oracles can offer more of like an inclusion. Users or that consume or use data from this network can choose to be part of the information or part of the mechanism of getting this information. So that is one of the advantages of decentralized oracles or decentralized networks. So one finality of decentralized network is that in terms of security, decentralized network has this way of preventing wrong information due to downtime or yeah due to network downtime or network delay because we are not depending on one user in order to transfer this information. So even if one third of the users or one fourth of the users of the nodes in that network have network issues, there's still trust that the remaining two third of those users is actually going to send in the correct information. It's going to send in the most recent information because there's basically almost no way that all the node providers or all the network or the nodes operating in that distributed network is actually going to have bad network or actually going to be malicious at the same time. So that's one of the advantages of decentralized network in terms of security. Then also you should also remember that I talked about Sibyl attacks. So decentralized oracles now are more prone to Sibyl attacks than centralized oracles. So if you are going to implement your own oracle, if any of you is going to design your own oracle, I want to design a decentralized oracle. So there's need for you to actually be able to make efforts or make, yeah, basically make efforts in order to prevent something like a civil attack from happening. In network, for example, networks like the TM network, we have things like the staking. So if if each node in the network is taking a very large amount, like for example 23 ETH, okay, for you to actually be a node provider in this Oracle, we want you to stake 23 ETH. That is going to be difficult for a singular entity to actually control that network because that singular entity will have to spend a whole lot of money. Have to spend 23 ETH multiplied by the number of nodes that user want to run. And most time, if an individual is going to actually have as much as that amount of money to stake and risk in order to carry out this malicious act, it's easier for the user to just spend his own money because if the user can have that large amount of money, then there's almost no need for it to actually be carrying out this malicious act. Though that's not always the case, but at least with that now you'll be able to weed out or prevent instances of a civil attack to an extent. So the next two we'll be touching is slower response time and also their use case. In decentralized oracles compared to decentralized ones, there is slower response time. This is due to the need for consensus because informations need to come in from different aspects, from different points of the globe. So there might be delay, there might be like just network issues, or some of these nodes now might be offline at that particular moment. So this whole thing might constitute or might come together in order to slow down the response time of this oracle. You might make a call to an oracle now, and that oracle actually say, okay, you're making a call to get the price of this. Fine, I'll ask my nodes to provide you with the price of this. You ask 50 people or 50 nodes to provide the price of that particular commodity. And these nodes are fetching the price from different sources and different stuff. So all of them are coming, taking their own time, individual time, to get the price of this commodity. That is one. After getting the price of this commodity at different time frames, there's now another process, which is the consensus. So they are bringing in prices in different ranges. So we have to actually combine these whole prices and get one price that we can return back to this user. So even after taking time to get this price from or to get this data from different sources, we are still taking more time in order to come into consensus on the final price that will be returning to this user. So these two steps now combined together might cause more delay in a decentralized oracle, leading to slower response time in decentralized oracles. Then another thing we're touching is the use case of decentralized oracles. Decentralized oracles majorly are mostly used in DeFi industries, token industries, marketplace, and governance protocols. So when it comes to DeFi, there's a whole lot of risk involved. There's a whole lot of money at stake. You have people carrying out swaps, large amount of swap, as in amounting to millions of dollars. You have people taking loans from systems. These loans now are based on time or based on the price of some commodities. So there's actually need for we to have a trusted system that not just the institutions can trust. For example, not just an oracle that Uniswap can trust. We need an oracle that we as users that make use of Uniswap can actually trust. Some use case like DeFi, governance protocol, and stuff like that will actually need a decentralized oracle that is not in anybody's control. Example, in governance protocol, we have DAOs. I don't know if you guys have touched on DAOs, but basically, DAOs are decentralized autonomous organizations. DAOs are more of like, okay, organizations, charitable organizations, or just normal organizations that are on chain. For example, you have how will I put it? You have your, which example will I give? For example, you have your clubs. Let's say, yeah, you have your clubs in here, and then you have the Rotary Club. We have some other clubs or some other group or meeting groups in school. But imagine if these groups now choose to come on chain, choose to come to the blockchain. So they are trying to set up Rotrats on the blockchain. That way now, there's no centralized authority. There's no way for you to say, okay, we are sending money for monthly contribution to Rotract, and our treasurer and our secretary, in combination with our president, are misusing our funds. So if you set up something like that or something like a group, Rotract group on the blockchain, that is what we call a DAO, a decentralized autonomous organization. So these things are organizations that are decentralized because they are on the blockchain. And some of these decentralized organizations now might actually need oracles in order to transfer data from real life in order to their blockchain, to their smart contracts. And since the reason why we are setting up DAOs is that we do not want centralized control, we do not want to have a president that is just autocratic, making a decision, deciding on his own. So we want something that is inclusive, something that anybody can have control over. Can anybody can just come to the audit, get access to it, like you. So if we have stuff like that, DAOs on the blockchain, there's need for the data that these DAOs are consuming to be decentralized. It doesn't make sense that we have a DAO that is decentralized, no centralized authorities over that DAO, but we are having a data source that is being controlled by one individual. So that actually contradicts the main aim or the main reason why we want a DAO. So that's why governance protocols, DAOs, and the rest, we choose more often to go for a decentralized oracle because they won't want to have a centralized bottleneck or a source of information that is being controlled by a single individual. So that is that for decentralized oracles. We've been able to cover basically the use case, the response time, security, trust, and also the fact that distributed network. So another aspect that I would like to really talk about today is randomness on the blockchain. So I know a whole lot of us, for everybody that is on this call today, you are basically already grounded in Web2. So you already have good knowledge of HTML, CSS, and JavaScript. And while building a front-end app, you might want to generate a random number to do something or to run in your logic. And for a JavaScript users, can just use any library or just random number, give it a range to choose from 1 to 2 or 1 to 10, 1 to 50. And JavaScript will basically run some computation and return a random number to you. That is actually not very possible on the blockchain. That is because, okay, blockchain by design are designed to be deterministic. What it means that blockchain are deterministic is that a blockchain is designed in a way that as long as you keep giving it the same input, it will give you the same output. As long as there's a logic and you keep giving it 10, 1 to 10, and it returns true to you. But every time you give it 1 to 10, it will return that same 2. So there's no implementation in the blockchain for it to keep changing, for it to like be able to change or like alter decisions and return something different to you, passing in the same input. In JavaScript, you want a random number. You're asking JavaScript to give you a random number from 1 to 10. Today they give you 1, tomorrow they give you 5, next tomorrow they give you 7. But when it comes to the blockchain, if you tell it, give me a random number from 1 to 10, it gives you 2. Tomorrow, if you pass in that same input, it will give you that same 2. Next tomorrow, it will give you that same 2. Because blockchains were designed to be deterministic. We want to know what is happening at every single period of time. We don't want to leave anything to randomness or to chance. So there is no good sort of entropy in the blockchain. But we are designing smart contracts and we need random numbers. There are instances where we just need random numbers. For example, we are designing a lottery contract. Each of us on this call now want to participate in a lottery contract. All of us, we are staking $50 or 50 USDT. And once one of us on random to be selected as the winner, that we take that entire amount that is being staked by the rest of us. In JavaScript, it's easy. can just use generate a random number, assign each of us a number from 1 to 15, which we are on this call. Then ask JavaScript to create a random number from 1 to 15. JavaScript to pick one number, and automatically that person is a winner. That's how we'll be able to implement this in Web 2. When it comes to blockchain, you are not able to get a random number because blockchains, like I said, are designed to be deterministic. So how else do we set up something like this? How do we write a smart contract that will be able to choose one out of us as the winner? So basically, when we are creating random numbers on the blockchain, we use pseudo random number generators. So these pseudo random number generators take a seed value and input, then generate a sequence of numbers that appear to be random. But just like I said that, okay, since in blockchain, we want everything to be deterministic, we want to be able to, and open, not just deterministic, but also open. There is no secrecy in the blockchain. So if there's an algorithm that is able to generate a random number from a particular input, we know that, okay, if you pass it this input, it gives you this random number. But in the blockchain system now, that input is open. Everybody knows the algorithm. Everybody knows the input you are given. So it will be very easy for you to actually manipulate, for users to actually manipulate that method or that function you come up with that's able to generate a random number. So you see that that is actually an issue in the blockchain. So by default, the blockchain cannot generate a random number for you. And even if you are smart enough to create a logic that generates a random number for you, your logic is actually open source. The input you are passing in, everybody can see it. The algorithm you are using in order to generate that random number is also open. Okay, so how then do we generate random numbers in this system? That is where oracles come in also. So aside oracles being able to pass in the price feed of goods and services or information regarding data or real life events that happen in the external world, oracles are also able to pass in random numbers to our smart contract. So since you know that oracles actually carry out implementation outside the blockchain, so you can trust that the logic or the medium of generating this random number can be happening outside the blockchain where other users cannot actually see the logic or see the implementation. Some of these oracles basically might also be even using JavaScript on the back end. So since it's carried up and they are getting the random number on the outside world, they use JavaScript to generate a random number. Then this oracle passing the random number back to our smart contract. So that is actually the most trustworthy and the most reliable source of randomness in the blockchain. Before now, some people were actually using random number, like you're using the block difficulty of a block. We know that okay, the blockchain is basically made up of decentralized ledger of transactions. Each transaction is bundled into block in order to be processed by the EVM. So each block now during the proof of work era has a random number that is determined or that is pinned as the difficulty of that particular block. And that block difficulty changes for every particular block. So previously, people were depending on that block difficulty in order to generate a random number. Since the block difficulty is determined by the network itself and no centralized user. So I can create a logic now that says, okay, pick the block difficulty for this particular block, run certain computation in order to limit it to the 12 of us that are in this call now, and pick one number from there as a winner. So it was possible previously because we had the proof of work where each block has a unique number, a different number as a block difficulty. But now that we've migrated from proof of work to proof of stake, it's not possible to get a block difficulty because there's no more block difficulty in this case. So right now, in order to generate random number, trusted random number on the blockchain, we all have to use, or as developers, we need to use a trustworthy source, which is an oracle. So just like I've been mentioning before, some of the challenges or limitations we have with regards to using on-chain source of randomness is predictability. Since your logic, the algorithm that generating this random number is open to everybody on chain, then it's easier for a user to predict the random number that will be coming out. If I say, okay, each of us on this call now, there's an algorithm that generates a number from 1 to 15, and each of us on this call is to pick a random number. Then when we pick a random number, the person that gets the same number that our contact reveals is the winner. Everybody here now knows the logic in that smart contract because it's opened. Everybody knows the inputs the smart contract is collecting. So we can run our own individual computation and get the number that that smart contract is going to decide. Then each of us now will be clamoring for that random number. And it's actually going to beat or it's actually going to derail the main reason why we are writing that smart contract to choose a random number or a random user within all of us on this call. So that is actually a problem. When it comes to random number on chain, it's very, very predictable and it's not something we can trust or depend on. Then collusion. In decentralized environment like the blockchain, malicious users or malicious actors can come together in order to decide or in order to depict or like in order to hack our smart contract, if you put it that way. So one of the reasons why this is here is before before now, some people, some developers, when they write their smart contracts and they need a source of random number, what they do go for is I think the block dot timestamp. Yeah, they can use the block dot timestamp to get as an input in order to run random computation and get a random number. The block dot timestamp is more of like the time at that period, like a time, a Unix time where a particular block is mined. So if a particular blockchain or a node provider knows that, okay, we have a contract that is using the block dot timestamp to generate a random number that it will pick as the winner of a particular like auction, a particular like lottery. If I'm the one generating the block for that period of time, I can choose that, okay, I'll generate this block at this period of time. That means if I'm generating this block at this period of time, the block dot timestamp for this transaction is going to be 15, for example. So if this block dot timestamp is going to be 15, this person's logic is going to collect 15 and is going to choose a random number, and that random number is going to be 2. So I can choose to, okay, I already know when I will mine this block. I know the number I'm going to choose. To see that the miner now can choose to collide with a user, one of us on this platform now, and say, okay, I'll mine this block at so time, choose 2. You get the reward. When you're rewarded this and the amount, who split it? So there's also a possibility of collusion in the blockchain space. Different parties that actually control the blockchain can actually come together to collude and defraud our system. So it's actually an issue. So that's why it's not advisable. One of the reasons why it's not advisable to actually use on-chain source of randomness. Then another thing is external data dependency. So just like I said, that the blockchain or algorithms or functions you write on the blockchain cannot actually on their own run and give you a random number. Even if you are smart enough to write a logic that is going to generate a random number, that logic needs to get an input. Then from that input is going to run certain computation like byte shifting and left and right, or division, multiplication, or some other complex logic on an input we give in order to get what we feel is a random number. So randomness on the blockchain always depend on an external data. We need to pass in an external data for it to generate a random number from that particular data, which is not actually nice. Because when it comes to other languages like JavaScript, Rust, C++, you just need to run a particular function, rando or get random number, stuff like that. And it's going to automatically generate a random number, sometimes even without passing in any argument or any input. So that is one of the issues or one of the limitations of on-chain randomness. So at this point, I'm supposed to start touching Chainlink. But before that, I would like to ask, are there any question or do you guys have, is there anything that is confusing at this moment?
Okay, can you hear me?
Yeah, I can hear you.
So my question is there any solution to this randomness of nature? Like, is there any solution to it?
Okay, so basically, when it comes to generating random numbers on the blockchain, the most possible and the most reliable source of randomness for the blockchain is through oracles. An example of such oracle is Chainlink. So on Tuesday is going to be our next class. So on Tuesday, we are going to be writing a live contract. We'll write a contract on the core, and that contract is going to be more of like a lottery contract. So I'll show you people how to use Chainlink to get a random number. So what we're going to do is that the contract is going to get a random number from Chainlink, then it's going to pick one of us on the call as the winner of that lottery. So you're going to see a live demo of how to use Chainlink now to get trustworthy randomness or random number that we can utilize in our smart contract. So I don't know if that answers your question.
Yes, it does. Thank you.
Yeah, you're welcome. So any other question before we proceed? Okay, I'll take that as a no. So we'll be diving straight now
So,
to,
good evening.
yeah, good evening.
So, will you be sharing the slide?
Okay, sure. If you want that, I could share the slide. That won't be an issue.
I said, will you be sharing the slide?
Sure, sure. After the call, I'll send the slide to our WhatsApp group.
Yeah, I do appreciate if you share it in the WhatsApp group. Thank you.
No problem. I'll do that. I'll do that. Okay.
Oh,
So,
thanks, sir.
no problem. Any other call? Any other question? Any comments? Okay. So we'll be going straight on to Chainlink. Um, Before now, I've been making mention. I've touched what oracles are, the disadvantage of oracle, advantages of oracle, types of oracle, decentralized and the decentralized oracles. So one of the major or most popular oracle we have in the space as of today is the Chainlink Oracle. So Chainlink is actually a decentralized oracle network that is built on Ethereum, though it's now able to offer services to other networks like Optimism, not just Optimism, Polygon, a whole number of blockchain systems now. So Chainlink is a decentralized oracle, and Chainlink is actually intended to be used now to facilitate transfer of temper-proof data from off-chain sources into on-chain smart contracts. And that is basically the definition of what an oracle is. So Chainlink is like so far so good. I think that's the only oracle I've ever worked with because it has all the implementation I've wanted so far and like so far so good. And it's actually like nice. They offer good services. So Chainlink is able to offer random number to a smart contracts. They are also able to offer the price of stocks, the price of tokens, and volatile tokens to a smart contract. So if you are building a swap, if you are building a bridge, if you are building any contract that needs the price of goods, the price of random number, we could use Chainlink in order to execute that. There's another implementation that Chainlink offers, but I won't be touching much of that in this call because it's a whole different thing. Chainlink offers automation. Automation in the sense that Chainlink offers automatic calls. I don't know if you guys have noticed, but basically our smart contract, in as much as we call them smart contracts, are actually dumb. No, yeah, I know we call them smart contracts, but they are basically very dumb. Dumb in the sense that by default, if you write a smart contract, that smart contract cannot implement or cannot execute any logic. It's not like okay, we have an app running on the back end that we can program that okay, at so price. If it's in Web 2, you can provide that, okay, at so time or at so interval, do this, do that, do this, restart or do this. When it comes to smart contract, they are very much isolated from the real world. So a smart contracts cannot implement any logic without a user, an EOA, kickstarting or an EOA making a call to that contract to implement or to call that particular function. But we now as developers, we might want to implement logic in our smart contract that need to be called at certain time. For example, I might have a smart contract now. Okay, for every day, I want that smart contract to make a call to all of us on this call now are members of that smart contract. So I want that smart contract every day to check all of us on this call, know which of us is celebrating our birthday today, then send a birthday message to that person. By default now, since our smart contracts are basically dumb, our contract now is not able to make or to implement something like that because which we need an external user to basically click a button to run that check. Click a button to run the check, run through, look through each of us on this call, check who is celebrating his birthday that day, and send a message. But what if me as the admin, I'm not available on that day, or I'm having network issues, and I'm unable to make a call to that contract? Does that mean our contract won't be able to implement or to run the logic it's supposed to run for that particular day? The answer is actually yes. By default, without any external backing, that is how the system will behave. If you have any implementation, there has to be an external call calling that particular contract every day to run that check. But with the use of an oracle like Chainlink, they have what we call an automated call. So with the automated call, you just set up Chainlink, connect your smart contract to Chainlink, then tell Chainlink that, okay, I want you to call my contract once every day. So once every day, Chainlink will just make a call to your contract. And by making a call to your contract, you can implement the logic that Chainlink will be calling to be check user's birthday. So if you know that, okay, every day you can even go and sleep, just set it up, go and sleep. Every day, Chainlink will make a call to your contract. The logic that's calling is to check each of us here who is celebrating our birthday for that day. Then send a message to that user. And that is it. That is the only way we'll be able to implement automation in our smart contract. So Chainlink now is able to offer this also in addition to sending us the price of goods and some commodities tokens and also providing random numbers to the users. So that is it. I think that's the three most active uses of Chainlink that I've actually made use of or that I've actually implemented in the smart contract. Yeah, so something you have your hand up.
Yeah, please, I have a question.
Yeah, go ahead.
Okay, you said we can use Chainlink to make automated calls to our smart contract, right? So I was
Yeah, yeah.
wondering, can we not do the same thing using Web2 servers or something like that?
Okay, using Web2 servers, that is actually is also possible, but you need a whole lot of expertise. Expertise in the sense that using Web2 server, you have to connect your Web2 server to the private key of the wallet because you know that the Web2 server now we have to make a call to our blockchain to our smart contract. And for you to actually make a call to our
Yeah.
smart contract, you need to have a wallet. You need to sign a transaction. So you have to design your Web2 server in a way that your Web2 server will be able to control a private key, then sign a transaction on chain with that private key. So
Okay.
that is possible. So if you have the expertise to do this, then that is good. You're able to implement that. But the problem now is that your Web2 server now is open to hacks. Your Web2 server is prone to DDoS attacks. So if you
Yeah.
want to actually implement a logic like this for a contract that needs that is in or that deals with money, that deals with finance, you see that there's an issue. Because what if your contract, what if your server Web2 server is hacked? What if users don't trust your Web2 server enough that you might manipulate your Web2 server to not send or not call the smart contract on that particular day and send me my birthday message because me and you have issues? You see that this is actually this is where the issues now might come in. So that's why we need a more decentralized source of automation And most people now make use of Chainlink because they know, okay, Chainlink is more of like a node service. Even if one node is unable to make that call, their other nodes are able to make that call for that particular day. So
Okay.
that's it.
Okay. Now the thing is that it is possible, but it might not be secured or something.
Exactly. It might not be secured.
All right. Thank you.
You're welcome. Okay, so that is that for a brief introduction to Chainlink. So what we'll be touching now is how Chainlink provides secure and reliable data. So I think I've really, if you guys have been paying attention, I've really touched on this like a whole lot. I've touched on decentralized network when it comes to oracles. But let me see, okay, touching that again. So basically, how Chainlink provides secure data to our smart contracts is that first of all, we need to understand that of node operators in the Chainlink network. So look at it like two blockchains. We have the Ethereum blockchain if your contract is on Ethereum with the node and
So we
everything
can't
coming
hear
to.
you.
Wow, wow. Sorry about that. Can you hear me now?
Sorry, I can hear you clearly. I can hear you clearly.
Okay, 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 okay. Then I think it's network on the person. I didn't get the person I was complaining, but I think network on the person's end is not good. So okay, let me continue. So I was saying we basically have two worlds. We have the on-chain world and the off-chain world. The on-chain world is where our smart contract lives in. The off-chain world is more of like the chain link or where chain link resides in. So what happens is that Chainlink now has a smart contract on chain also. So we integrate Chainlink, or basically in our smart contract now, we pass in Chainlink's smart contract address into our smart contract. So if we need data of any source, Chainlink specify the kind of the function you are supposed to call for a particular data, or the smart contract you are supposed to call for a particular data. For example, I'm on the call. We also have Jerry here on the call. So both of us, imagine if both of us now are Chainlink agents, and you as a user, you are designing a smart contract. Chainlink now might tell you that, okay, if you have question regarding, if you need data or information regarding this class that is going on, ask me. If you have questions regarding the bootcamp or the training in general, ask Jerry. So that is how Chainlink runs these implementations. There are different contract addresses. If you want this information, if you want the price of ETH, call this address and ask. If you want the price of DAI or Uniswap or Uni, call this contract and ask. If you want the price of Link token, call this contract and ask. So that is how Chainlink breaks down this information into different contracts. And each of these contracts is on chain on the Ethereum network. So our this contract, Chainlink contract, is what we call the data request. So our contract make a request to this Chainlink contract. So Chainlink contract now probably emits an event, or yeah, emits an event that is being picked up on chain, off chain by Chainlink off chain implementations running that is scanning the blockchain, waiting for events to be emitted by their Chainlink contract. So once these events are emitted by their on-chain contract, their off-chain implementations pick the events that are emitted. When they pick the events that are emitted, they get the request. Okay, so contract address is requesting for the price of ETH at this moment. So the off-chain implementation is like the entire nodes in the Chainlink system. So the node now pick up this your request. They run a call to their external API or their Web2 APIs, probably CoinGecko, crypto.com or stuff like that, get the price of ETH at that particular moment, come into consensus on the active price or the real price at that moment. Then they send this information back to the smart contract. So that is actually how the process goes on from data request to data return. But this most often is in the sense of like, okay, if you are actually requesting for the price of goods or commodities, where consensus needs to come or consensus needs to be arrived at. But if, for example, you just want requesting for a random number, there might not be a need for consensus. There might not be a need for 15 networks to come together and choose that, okay, yes, this is what this is random number we came out and stuff like that. So a singular requested by that smart contract at that particular moment. So that is that for node selection. But if you are requesting for price of goods, price of commodities, and stuff like that, there's need for data aggregation. Data aggregation is basically okay. A smart contract is asking for the price of ETH. Each of the node in the Chainlink network fetch the price of ETH from their different source. So data aggregation is all these nodes bringing their data together, multiple nodes retrieving data from different sources and submitting that data for consensus to actually take place. So after the aggregation, the next step is data validation. So Chainlink nodes validate the data that they receive. They come into consensus, validates the data. Okay, is this person sending the right information? Is this person sending the wrong information? They come into consensus on the final price that they are going to actually send to the user. So when they validate this data, come into consensus on the final price or the final data or information they are going to be sending to our smart contract. Then they make a call to the Oracle smart contract that is on chain. So the Oracle Cosmos contract that is on-chain manage the interactions. So they are more of like the Oracle smart contract is more of like a middleman between our contract as developers and the off-chain source. So what this Oracle smart contracts do is they receive the final validated data from the Oracle, the off-chain implementation of the Oracle. Then they send that data to our individual smart contract. So that is more of like a response, just like the way we have in our web to have request and response. Initially, we make a request to the Oracle smart contract. The Oracle smart contract contracts the job off chain to the nodes. The nodes complete the transaction, send it back to Oracle smart contract. The Oracle smart contract now send the data again back to our smart contract. So that's basically the way of the interaction or the circular interaction between our smart contract and the off-chain world and how they get the data on-chain. So I know I've been explaining what oracles are and the rest, but I don't know if you guys have actually had time or thought about why Chainlink or why oracles will be offering out these services, because these services basically is going to need a whole lot of computation. They're going to be needing servers that will be running on chain or off chain continuously without downtime. They're going to be needing node operators that will continuously have their system on and the rest. But why will anybody want to do that for free? And the answer is that when you're making use of oracles, Chainlink oracles, and some other oracles, they are not actually free. Some of the services might actually be free, but some service like the random number generation is not free. If you are going to be needing a random number from Chainlink, for Chainlink, as in to be precise, Chainlink itself, you actually need to actually hold link tokens. Okay, so for you to use Chainlink or to make a request through Chainlink as a developer for a random number or some other information or data, you need link tokens. So you make payment for the data you are requesting or for the information you are getting from Chainlink. You make that payment in link tokens. So I've forgotten the actual amount, but for each random number Chainlink sends to you, they collect a particular amount of link tokens from your account. So when you're writing a contract or a implementation that needs a random number, you have to set up a gas tank. And in that gas tank, you're going to fund enough link tokens. Even if you are making calls, like you're setting up an automated call, a call to your contract every day, Chainlink is not going to be paying the gas fee continuously for you for free. So you need to set up a gas tank. You fund the tank, or the gas tank is more of like an account that is being controlled by you and Chainlink. You fund the gas tank, the account with enough link tokens. So Chainlink will be deducting from your account for every call of every data they pass to your smart contract. For every automated call they make to your smart contract, they deduct a certain amount. So the whole Chainlink Oracle system is more of like software as a service or platform as a service. I don't know which of them in particular, but it's more of like software as a service. You're making use of your software, making use of your implementation, and you're paying them for it. So it's more of like a business for them. So that's why the last section in this slide is here detailing payment in link tokens. So and the payment you make to Chainlink is actually how they are going to be able to incentivize node operators. Because Chainlink being a decentralized oracle needs individuals like you and I running nodes, running Chainlink nodes in order to send in data from the outside world to use our smart contract. So if any of us is going to be running a node, they need to be a way to incentivize us for our time, for our machine, for the data and also electricity costs and stuff like that. So the payments that Chainlink charge from users making use of Chainlink is how they'll be able to incentivize or pay their node operators in order to be able to continuously transfer information or continuously relay information from the off-chain world to smart contracts. So before that, I would like to just I think I'm sharing just this slide. Okay, what will happen is a link to Chainlink website on the chat. 1 minute. I need to reshare my screen, so I'll walk you guys through. So can you guys see my screen?
Yes, I
Hello?
can.
Okay. So if you visit
Yes, sir.
the website I just sent on the chat of this call, it's going to take you directly to Chainlink website. So on visiting this website, you're going to be seeing Chainlink data feeds and stuff like that. So each of these now is price feed that Chainlink can provide from the external world to your smart contract. So if you need the price of ETH, USD, BTC, USD, that is the price of Bitcoin, USDT, and USD. Each of these like information is available or can be relayed by Chainlink. And just like I told you that for each information, Chainlink provides an address or let's say an individual that you call or ask for this data. So this address you see here are individual addresses that you need to call in order to get this price feed or the price of these individual currencies. So let's take ETH for example. If I want to click on ETH you see Chainlink is actually giving us the price of ETH at the moment, and is pricing it as 1,676. Then it's telling us the amount of the stake that each oracle, or the combined stake that these oracles have come together to stake in order to be able to transfer data on chain. Then, just like I told you, that Chainlink is able to send information not just on a Ethereum network but on that network. So here is telling you the list of networks that can provide this data to. So if you want the price of ETH USD on, and you want Chainlink to send you this data on your smart contract that is on Gnosis or Optimism or Polygon or Moonbeam, Chainlink is going to be able to send you this data. Then one thing I would like to talk about is the individual oracles, the nodes in this network. So Chainlink is the oracle, yes, but there are nodes that are coming together to transfer or to bring in price from different sources, and that is what we see at this point here. So we have we have about 31 different nodes bringing in data from different sources. And I was telling you that when multiple people are transferring data from different sources or different points, there's always going to be difference in that data. So we see that, okay, this first oracle here is passing in 1,000. Let me increase my screen. Oh, sorry. Can you get my screen clearly? I need a response, please.
Yes, we can. Yes, I can.
Yes.
Okay. So you see that there are different oracles now, or different nodes providing the data or the price of ETH from different sources. This first oracle is sending in 1,676.13. The next one is sending in 1,675.95. Another one is sending in 0.25. This one 0.29, 0.38. So you see that each of these oracle is going to actually be sending a different price. But Chainlink now in general, we have to come into consensus. So it will have to aggregate all these different prices that these nodes are sending, combine it together, then bring about or get the final price that is going to showcase to or send to the user's contract. So after probably running the mean or getting the average of this entire data that these different nodes are providing, Chainlink was able to arrive at the price 1,676.26. So this is the actual price that Chainlink will be sending to smart contracts that are requesting for the price of ETH at the moment. So probably in your free time after this call, you could go through Chainlink website, just play around. You get to see the numerous price feed they offer and other stuffs or other use cases for Chainlink, like the verifiable random number and some other stuff. So just play around the websites, check it around. Then if you have any questions, you can drop it on the group chat. I'll be available to help answer these questions. So going back to our slide. So while while oracles are actually beneficial to our smart contracts and the use cases we have for the smart contract, there's actually great need for oracles to be very secure, oracles to be reliable, and there's need for oracles to be trustworthy. So oracles needs to put more effort in maintaining and ensuring data accuracy and security. So this is more of like a challenge in Oracle system, because coming into consensus on the correct price of goods and services is actually a big issue, because when you're getting the mean from multiple users, there's always a possibility that you are getting a mean or a number that by certain calculation is off the actual price. When we checked Chainlink, we got the price of ETH to be 1,676. I'm very sure if you check Google at this moment, it's going to give you a price that is about 0.5% higher or lower than that. So that is actually an issue with oracles. Oracles is difficult for an oracle, especially decentralized oracle, to actually give you the exact and 100% accurate price or data due to the fact that coming into consensus from data with data from different sources is actually an issue. So there's great need for more efforts to be made or more research being to be made on data accuracy and security in the blockchain or oracle systems in general. So rounding up, I would like to touch use cases of blockchain oracles aside what I've just mentioned or the numerous examples I've given during the course of this discussion. So we could also use oracles for payments confirmations. So there's much research now. I think there's a project I know of, I've forgotten the name. But what they're actually working on is integrating card payments into the blockchain. So, for example, you're building a smart contract that can actually accept payments from credit or debit card. So, what it basically does is that there's probably a Web2 interface that will prompt users to make payments using their credit card. So, once the payment is processed, they have an oracle that will make a call to your smart contract to let your smart contract know that this user has made this payment and this is the amount the person made. So the price and the fact that the user made a payment using his credit card is an off-chain information. So they have an oracle that once user makes that payment, the oracle will let your smart contract know that this user has made this payment. Then your contract now can implement any logic that you've set in place to run if that particular user makes that payment. So I also give an example of supply chain tracking. When I mentioned that we could use a barcode scanner as a hardware oracle to track the goods that we are transferring from Enugu to Abuja from any other source. So oracles can be used in supply chain tracking and management. Then insurance claims also could also use oracle system because today we have multiple insurance like the full stack insurance we have on Web2. We have dApps or companies have set up that insurance system on the blockchain. So when it comes to data, like when you're coming to claim your insurance data, insurance for particular damages or particular issues that must have happened, there's a need for a secure way to transfer data, information, or basically information that happened on the main on the real world to this insurance smart contract. So that's one of the use cases of blockchain oracles. So blockchain oracles could be used to transfer information, reward information of damages, of accidents that must have happened to the smart contracts in order for to help process insurance claims and stuff like that. So blockchain oracles are also used in decentralized finance for getting price feed, for getting for in also lending and borrowing, for getting rates of lending and stuff like that. Then finally, it's also used for automated calls. Just like I mentioned before, that you can use Chainlink in order to make automated calls to your smart contract, depending on how you program, how you set up your automated calls. Then under the future trends of blockchain oracles, we know that so far so good. The current architecture we have with blockchain oracles is kind of like streamlined. It's kind of, let's say, how will I put it? It's not fully decentralized per se because blockchain oracles are still being controlled by a certain group of institutions, just few institutions offering blockchain oracle systems. And so we have to limit our smart contract. We have to limit the logic we have basically to the data we can get from these oracles. So imagine if we now as Africans, or we now, basically as Africans, we want to create a smart contract or a platform that utilizes the price of millet, the price of corn, or we now that most of us being student of UNN, imagine if you want to create a smart contract that is able to tell the price of okpa at the moment. So that is not actually possible. You want to create a blockchain app for users, for users or students in UNN, and you need users to pay for OPA using like cryptocurrencies. There's actually no blockchain model for now that will be able to tell you the price of OPA at the moment. So you have to restrict your contract logic to the data you can get from oracles. But I believe in the nearest future, we'll be able to create more open source oracles. I think there's also a project that I'm supposed to work on. So you're supposed to create a system or implementation for users or for developers to actually design the data source they want. So imagine if you as a smart contract developer, you can set up a Web2 backend, a Web2 API points, multiple Web2 API points that oracles now can just plug into, then send that data to your smart contract. So it's going to still be an oracle, but it's now more of an open source oracle that will allow users to design or structure out the kind of price feed they want, the kind of data they want. So that is more of like a future roadmap that I feel is going to happen within the next couple of months or the next, like probably the next few years coming. Then, in summary, blockchain oracles are actually a key aspect in smart contract dApps development. Without blockchain oracle, I don't think we'll have implementations like Uniswap, other lending pools, Uniswap, Pancake, Ave, and the rest in place today. So blockchain is a very, very integral part. It's more of like a bridge between, just like I said, a bridge between the real world and the on-chain world. Without the blockchain, without the oracle, it's going to be very, very difficult to actually run most of the implementation, most of the logic you have on the blockchain today. So that is it for today's class, and thank you guys for listening. So at this point, I would like to entertain call questions. If you have any questions or if there's anything you do not understand or you need clarifications on, so please specify.
All right. Thank you so much, Chinonso, for the class tonight. It was very insightful. The slides could it be available on like the web chat?
Sure, sure. I'll drop this slide immediately after this call on the WhatsApp group.
All right, no problem. Okay, guys, thank you so much for coming around. We'll continue again on Tuesday. Continue the classes on Tuesday. Just try to be around. And I think that'll be it for the night. Good night, everyone.
Yeah, good night, guys.
Nice,
Thank you.
sir. Thank you.
Thank you.